This video shows how programmable control can be implemented with PLCs by converting the hardwired relay ladder logic to a PLC program. This hardwired motor control circuit will be converted to a PLC program. There are three inputs: a normally closed stop switch, a normally open start switch, and a normally closed overload contact. There are three outputs: a red pilot light, a green pilot light, and the motor M. The hardwired circuit is converted into a PLC program. We still have our three inputs on the left and the three outputs on the right. The logically hardwired connections have been replaced with PLC instructions. This is a simulation of a simple start-stop motor control. The motor output will be energized when the stop button is not pushed and the normally open start push button is pushed, or the motor is energized and the overload switch is closed. The red pilot light will be on if the motor is energized, and the green pilot light will be on if the motor is de-energized. Pressing the normally closed stop push button will de-energize the motor and turn on the green pilot light and turn off the red pilot light. When the motor is energized, opening the switch that simulates an overload of the motor will de-energize the motor. When the overload switch is open, pressing the start push button will not energize the motor. On the top left is a schematic for a hardwired logic circuit consisting of two normally open limit switches, LS1 and LS2, connected in series with the output solenoid. On the right is the distinctive shape logic symbol for an AND gate and the Boolean equation. At the bottom is the PLC logic program. All three will perform the equivalent logic function. The output will only be energized when both LS1 and LS2 are closed. When the two limit switches are connected in parallel, the solenoid will be energized when either LS1 or LS2, or both LS1 and LS2 are closed. Note the distinctive shape symbol and the Boolean expression for the OR function. The interconnection of the switches determines what logic function is performed. In this case, LS1 and LS2 are connected in parallel, or in OR configuration, and these switches are connected in series with a pressure switch to energize the green pilot light. The green pilot light will be energized when the pressure switch is closed along with either or both LS1 and LS2 being closed. In this circuit, we have replaced the pressure switch with two flow switches in parallel. Now the red pilot light will be on when at least one limit switch and one flow switch are closed. Another arrangement of the switches will turn on the horn when either LS3 is closed or both LS1 and LS2 are closed. This arrangement of switches requires LS1 and LS2 to be closed, or LS3 and LS4 to be closed to turn on the red pilot light. A normally closed contact changes the logic. In this case, the solenoid is energized when the LS1 switch is pushed and the momentary push button is not pushed. This arrangement of logic has its own name. The output Y will be turned on if A is pushed and B is not pushed, or if A is not pushed and B is pushed. Another way of saying this is the output will be on if A or B are pushed, but not both A and B. This is called an exclusive OR XOR. An extra stop and start switch have been added to the simple motor starter. The motor will be energized when neither normally closed stop switches C or D are not pushed, and either normally open start switch A or normally open start switch B or the contact M is closed. The contact M will be closed when the motor is energized.